Hello, everyone, and thanks for attending this seminar today. My name is Michael Navid. I'm the Vice President of Marketing and Business Development at Megachips. I'm also an active member of Landmark International. First of all, I would like to thank AHR Expo and Landmark International for organizing this seminar. I'm really sorry I can't be there in person, but I'm certainly there in spirit. I have attended this conference for the past many years and I truly enjoy it. Today I'll be talking about a communication standard developed specifically for smart cities and smart building applications. It's the latest in wireline communication technology based on an IEEE standard, addressing the new requirements in terms of data rates, robustness, range, security, and most importantly, cost. Over the past few years, we've all seen a dramatic increase in the bandwidth demanded by modern building automation applications. More nodes, bigger packet sizes, more security. All of these things, as you can imagine, increase the amount of data traffic in industrial networks. Older technologies like RS-485, they struggle to handle all these data. Ethernet is too expensive to deploy, especially in older buildings, and wireless has an issue with line of sight, with security, and other complexities. Now you have another option. The technology is called HD-PLC. It's a high-speed wireline technology that's developed for the industrial IoT, including smart buildings. Landmark International adopted this technology a few years ago, and recently it's become an ISO IEC standard. Interoperability and certifications been developed and is provided through Landmark International and HD-PLC Alliance to ensure interoperability amongst different manufacturers. Today, I'll be giving you an overview of the new technology, its specifications and features, and I'll do a comparison between HD-PLC, Ethernet, and RS-485. Before we get into the technology aspect of HD-PLC, let's talk about some of the markets and applications that can take advantage of this technology and the overall opportunity. It's estimated that there'll be more than 50 billion connected devices globally by 2025, and the two biggest market segments in terms of revenue are industrial internet and smart cities. The picture shows all the applications we talk about when we're talking about smart cities. It includes smart buildings, smart grids, smart homes, smart factories. As these networks get bigger and more complex, and as the flow of information through the cloud increases, the need for higher bandwidth, higher security, the ability to support larger number of nodes, and long-range communication becomes more apparent. For this, a new communication method needs to be envisioned and planned for. The method not only has to meet customers' application requirements, but also address the cost of implementation. This is especially true in smart city applications such as smart grids, building automation, street and public lighting, smart homes, security and surveillance, and many others, where a new network must be deployed to meet today's requirements for communications. There are several options available to system integrators and building managers today, from installing highly complex wireless networks to very costly wireline installations like Ethernet. Today, we'll be talking about a wireline communication technology that not only addresses the requirements of today, but takes us for the next 10 to 20 years. So let me start off by giving you a short background on how this all started. We were approached by several key manufacturers and system integrators in the industrial IoT sector, and what they all told us was while they would like to stay with their existing communication protocols such as LoanWorks, BACnet, KNX, they were dissatisfied with the limitations of the physical network itself. they felt it no longer supports the new requirements of IoT. Things like faster data rates, higher security, robustness. Also, they had other concerns such as availability, the solution competitiveness, and cost of deployment. In addition, they saw many of the industrial and building automation applications are converging. So they wanted a single network to handle all their communication needs, from running their most demanding video application to some simple controls. When we look at all the key system requirements, need for higher data rates, supporting more nodes, longer range communications, IP-based, high security, faster response times, from an end application point of view, and when we are deciding which technology best fits today's requirements, the one technology that stands out is broadband power line. That's closest in meeting all the requirements of their end customer. HD-PLC is an OFDM-based power line communication technology developed to address the industrial and building automation market, as well as many consumer applications. It's based on IEEE standard 1901 and ITU G.9905, which is the routing layer, and now being supported by Landmark International as a new standard channel for LAN. In the next few slides, I'll be giving you an overview of the technology and comparing it to some of the more popular communication technologies in use today, such as Ethernet and RS-485. If you've been in this space for a while, you already know that existing communications technologies require difficult trade-offs. With serial communications, such as RS-485, you get longer ranges, but have to sacrifice speed and are limited to the number of nodes you can support, among other installation complexities such as grounding issues, as well as cost of pulling new wiring and so on. Low-speed wireless holds the promise of easier deployment, but range is an issue. Limited data rate, latency is an issue, especially in larger networks, and security, as wireless signals can get easily jammed. Of course, low-speed narrowband PLC offers the lowest deployment cost, but narrowband solutions, you're limited to kilobit speeds, and it's not robust enough for a lot of the mission-critical applications. And lastly, Ethernet. It's been tried by several companies. It addresses the speed, but its short range is an issue, and you're limited to the number of nodes you can connect. And the cost of installing Cat5 wiring and the expertise that's required, it keeps many projects from getting off the ground. Here's what's so special about HD-PLC. For starters, it gives you a big performance upgrade from kilobits to megabits, so you can send bigger packets more often, reaching more nodes at faster speeds in larger network configurations. You get the plug-and-play simplicity, free topology, and IP-based mesh networking, and works over any wiring, AC/DC power lines, coax, twisted pair, Ethernet, doesn't matter. We use the copper to transfer data. Today, it is typical to see multiple technologies used in buildings, from RS-485 to Ethernet to wireless and others. Wouldn't it be nice to have a single communication technology to handle all your applications, from controlling a single actuator to running the most demanding applications such as your high-definition security cameras, all using the same network throughout the building? Well, HD-PLC gives you all that. And the biggest benefit is you get all these capabilities without having to add or replace any wiring. Big performance advantage, lower deployment costs. It's a win-win for manufacturers, system integrators, and project owners. Let me back up and review some of the key characteristics between various wireline technologies in use today and how HD-PLC stacks up against them. The x-axis shows the operating frequency for some of the more popular wireline communication technologies, and the y-axis shows the relative range to each other. So here, the lower the frequency band, the longer your transmission. As an example, RS-485 on this chart operates at the 9.6 kHz, having the longest range, versus Ethernet operating at above 125 MHz with the shortest range. Broadband PLC is in the middle, operating between 2 to 100 MHz. One of the unique features of HD-PLC is its repeating function. It extends the communication range comparable to those of low-frequency technologies and performance of those of high frequency. With HD-PLC, you get the range of RS-485 and the performance of Ethernet and simplicity of wireless. Here are the key specs for HD-PLC. First of all, it is standards-based. We use an internationally accepted IEEE 1901 for the PHY and the MAC layers, an ITU G.9905 standard for the routing. The routing layer is very robust and specially defined for industrial networks. I'll be talking about that a little later, but it is what enables the repeating function of the data for long-range communication, supporting more nodes, and the mesh networking. The operating frequency is between 2 to 125 megahertz, achieving speeds of 1 gigabits per second at the PHY layer. It uses many of the same schemes as Wi-Fi and other advanced high-speed communication technologies, such as OFDM, which allows a more efficient use of the frequency band, thereby allowing us to add more advanced forward error correction algorithms such as convolutional coding, Reed-Solomon, to achieve a more robust transmission, provide faster speeds, lower latencies, and a more robust channel for communications in general. It supports both IPv4 and IPv6 that's defined by IETF. We have implemented a very strong encryption engine based on AES-128, which was developed by the U.S. Department of Defense and approved by NIST, which is the National Institute of Standards and Technology in the U.S. We've also implemented an inter-system protocol which allows coexistence with other wireline technologies without interfering. Also, HD-PLC is supported by many internationally recognized organizations. Interoperability and certification, as I mentioned before, is done by the HD-PLC Alliance as well as Landmark International. So we are hoping to get more people involved. We are now working with members of BACnet and KNX to gain their support as well. We are hoping that this technology will become the de facto standard for smart buildings and smart city applications. One of the newest innovations in broadband power line worth talking about is flexible channel wavelet OFDM that I talked about a little bit in the last slide. It's included in the latest IEEE 1901-2020 standard. HD-PLC is the only standard supporting this scheme. It gives users 15 user selectable channels to pick from, depending on their application. As an example, if you're looking for high-speed, high-definition audio-video applications such as security cameras, or high-speed internet throughout the building, you may want to pick the wideband channel. Whereas for simple control applications, you may want to pick lower frequency channels. Or let's say you want to have two or more separate networks running at the same time. You can configure the chip to have one network run on one frequency band and the other on a different frequency band without interfering with each other. It's a very powerful feature for manufacturers to optimize their solution based on their specific application and the environment they're working in. Another innovation is the use of a routing technique called CMSR, which stands for Centralized Matrix Source Routing. As I mentioned, it's based on ITU standard called G.9905. The protocol was defined specifically for industrial networks where longer ranges, support for larger number of nodes, and robust communication is required. It allows any node to act as a repeater. With this technique, you can extend the range of broadband power line by 10 times to several thousand meters. Of course, range depends on many factors, so it's hard to be exact, but this can give you a good idea of its capabilities and power. We call this feature multi-hop. In addition, with this method, since the master handles all the transactions, we can drastically reduce the network traffic, allows having larger networks and faster connections. Our customers are seeing authentication times of less than 30 seconds for large networks of 600 nodes, and the time from the time they turn on their system. The system continually monitors the lines and dynamically selects the best route to transmit the information to its destination. What we call automatic routing with dynamic self-optimization and self-healing features. We also added another feature such as dual master capability, where if one master fails, the system automatically changes one of the terminals to act as a second master. Again, our whole goal is to provide the most robust communication throughout the network, and I think we have achieved that with HD-PLC. Here I want to give you a high-level comparison and key features amongst the most popular wireline communication technologies such as RS-485 and Ethernet, and see how HD-PLC stacks up. Starting with typical communication speeds and range, here RS-485 has speeds of 10 megabits per second for short range communication of less than, let's say, 10 meters, and goes down to about 100 kilobits per second as the range increases, and this is mainly due to cable loss. For Ethernet, although you get the high speeds, you're limited to 100 meters. As TCP/IP networking moves from the home and office environment into more industrial applications, the 100-meter range limitation of Ethernet cable becomes a big problem. In large facilities, when you have to extend your network across several buildings and to remote sensors, it will require a bit more range than that. Also, you're limited to the number of devices you can connect to Ethernet, and it requires costly switches. Here, HD-PLC gives you the best of both worlds. Here we offer two versions depending on the application. One for high speed and the other is for range. In either case, the performance is better than either RS-485 or Ethernet. As for the number of nodes that can be connected, to a single network, you're limited to 64 nodes for RS-485 and around 100 for Ethernet, again with the use of several switches. With HDPLC, you can go up to 1024 nodes on a single network. HDPLC is IP-based. It supports both IPv6 and IPv4. It's plug and play, which means you can cut anywhere on the cable and install a device without having to configure it. The system automatically knows when a new device has been added, and it will authenticate it, and if it has the right permissions, it'll add it to the network. One of the biggest advantages of HDPLC over those other technologies is its level of security. Not only you are using your own wiring infrastructure, which can provide a level of security from external threats. We have added AES-128 encryption, as I mentioned before, to give it the highest level of security. AES-128 was developed by the Department of Defense, and it's one of the strongest encryption engines in use today. The primary weakness with Ethernet is that it is a broadcast system. Every message sent out by the computer on a segment of Ethernet wiring reaches all parts of that segment and potentially could be read by any other computer on that segment. We have solved that problem to a large extent. Another advantage of HDPLC is its mesh networking and repeating functionality. The system knows exactly the conditions of the line and finds the best route possible to send the packets. Also, with the repeating function, every node can act as a repeater for a more robust and wider range. Another feature that includes installation that reduces installation complexities is that HDPLC uses free topology, which means you can use any type of topology, whether it's ring, bus, mesh, star, whereas RS-485 and Ethernet are star and peer-to-peer topologies only. Lastly, HDPLC can work on any wiring, whether it's twisted pair, coax, Cat5, even phone lines. We only use the copper as the means to transmit and receive information, which it really means you can take your existing RS-485 system on twisted pair and upgrading it to an IP-based system by just replacing the hardware at each end of the cable. You don't need to pull new wiring where most of the expense is usually, or you can run it over existing power lines where it makes sense. The same wires that provide power to the device can also transmit and receive information. The point is, you have so many options with HDPLC, and you can optimize it based on your needs. When you look at building automation today, it consists of many individual networks with various protocols and types of wiring. You have twisted pair for your HVAC control lines, coax for your security cameras, a different network for your access control, and so on. What truly defines smart buildings is the integration of these many, what I call islands of automation, into a single network. As I've mentioned many times during my presentation, broadband power line uses existing cables to transfer data. Whether it's coaxial cables or twisted pair cables, doesn't matter. So you can envision reusing the existing wiring infrastructure in the building as a transmission medium and create a single control network for all your building automation needs. In the case of using power lines, both power and transmission and data transmission throughout the building. Broadband power line creates a valid solution for the building and floor level communication, especially for solutions that are a fixed part of the building itself, such as HVAC or access control, and for direct communication from a building management system and property management to each room. This avoids a separate technical network, reducing running new cabling. So how does it work? HD-PLC provides a simple bridging function between these islands of automation. It can be used to extend Ethernet to every room, or bridge between Ethernet and twisted pair. Upgrading your RS-485-based control network to high-speed IP-based system by just adding an HD-PLC modem at each end of the cable. You don't need to pull any new wiring, where most of the expenses usually. Or you can run it over existing power lines where it makes sense. The point is, you have so many options with HD-PLC, and you can optimize it based on your needs at a fraction of the cost and time it takes to install a new network. We are coming to the end of my presentation today. Here are some of the key takeaways. HD-PLC is a new high-speed wireline communication channel standard for smart cities and smart building applications. It offers higher data rates, more security, and has a wider coverage than many serial communication technologies available today, like RS-485, and gives you longer ranges, supports larger number of nodes, and certainly lower cost than Ethernet. It works on any wires and offers free topology. It is protocol independent. Currently, we have ported LAN over to our chip, and we are working with BACnet and KNX in the coming months and years to get their support and adoption. It's a great option for your retrofit projects, where reusing the existing wiring infrastructure can save a lot of money for your customers. I know interoperability and certification is of high importance to this industry, and it's available through HD-PLC Alliance and Landmark. Also, this solution is available from several chip makers to ensure availability and long-term support. I know that this is another important factor for our customers. So with HD-PLC, I believe we have achieved all we were asked by our customers and the industry as a whole, and met the challenge. We hope you now take advantage of it and consider it for your next project. I would like to thank you for your time today and remind you to visit our webpage for more information on our products. There is a wealth of information there to help you make a better decision when it comes to your communication and networking needs. Thank you very much.